So hello everyone, I am Gong from Databricks. So it's a pleasure to talk about AI functions with my colleague Shitao here. So for today's presentation, it's going to be three parts. The first is why large language model is important for the business. Number two, what's the gap for SQL users to use large language model today? And number three, what is Databricks' solution to that? Okay, let's continue. So large language model is powerful. Since the release of ChatGPT in June 2020, the models from OpenAI has demonstrated this match human or even beat human capabilities in most of the Turing test style evaluations. This is amazing. For models with this quality, it opens up a new world. So let's think about a synthesized, very simplified use case. I don't think I can use a real customer use case here. So for a company, it can have tens of thousands of customer reviews. And it's important for the company to really understand the customer feedback and use that to help them to improve the product. Traditionally, a company will need to hire a specialist to read a big blob of the customer reviews, synthesize or analyze this in their brain and figure out, okay, this review is negative. And the reason why customer is not happy is because of this 50% defection rate in the product, which is really big. And it's better for the company to react to this as soon as possible. So those specialists will need to go over those reviews one by one, do the tagging one by one, and just repeat this work. And then they will do the synthesize and produce the summarizations about the customer reviews in a report and send back to the company. So this process is usually very time-consuming and expensive. The company will need to spend thousands of dollars to do this just once. And it always takes weeks to months to this process to finish, and which is not ideal. Luckily, with large language model, it can process the review and generate an answer with the same quality within just a few seconds, or even milliseconds. And because it can be done so fast, this model can process the whole review corpus within just a few hours, and the cost is going to be no more than a few bucks. So, because it can do things so fast and so cheap, now the company can monitor their customer reviews in a real-time fashion, which allows them to react to major product issues in a much faster way. So this level of productivity improvement and cost reduction is just revolutionary. This is 100x to 1,000x. As Forbes has put it, professions who can harness the capability of large language model will undoubtedly gain competitive advantage over those who don't. So it's the same for companies. For a lot of companies, including Databricks, how successful they can be in the future will highly depend about how fast and effective they can adopt this new technology. So now we have a promising future. We know this is important, and we know it is achievable. However, there are still practical gaps that requires a lot of engineering to do the task in a productionized, safe, and scalable way. So going back to this example, assuming right now I am a SQL analyst, and I want to do this customer review analysis work. What do I have? I have a reviews table stored in my Delta Lake, and the actual customer reviews is stored in this text column of this table. And I have an OpenAI API that I know can do the task. But what the heck can I have the two of them to work together to do the work I want? Okay. So first of all, I will need to get access token from OpenAI, and I will need to store that in a credential manager. And then I will need to write my own code to load this model into memory. To load this review table into memory in a string fashion if the table is way too large to fit into memory. I need to interact with this credential manager and loop through each rows in the table. I need to encode a row into an HTTP request that's based on this API specification of OpenAI. And I need to send over the network and get a response back. And then I will need to decode this model predictions from the response and save that as another column in the table or in a new table. During this way, I will need to handle those edge case failures, like those network issues, those rate limit issues, those bad request issues, those OpenAI is overloaded, please try later issues. And because I want to run this in a productionized way, I want to run this in a continuous way, I also need to make sure there's token rotation to make sure things like the access would be safe. So that's a lot of work, but maybe that's still manageable, and I'm smart enough to set those things up. So what if things change later? Say, we figure out that there's sensitive information in those customer reviews, or there is some regulation changes that doesn't allow us to send our data to a third party anymore. What do I need to do? I will need to set up large language model inference by myself. So what work it takes? Once identified what model I want to use from open source, it should have a commercial license. I will need to do these optimizations myself to make sure I can get the hardware acceleration. By the way, so 80% of the cases for large language model requires acceleration because it's large and it's complicated. Then I will need to package this model into a container. During this process, I need to make sure those library dependencies is set up correctly. The CUDA library version matches with the hardware I want to run it on. And those other libraries like PyTorch or TensorFlow version matches with the CUDA version I am using. This is very tedious. So once this container is packaged, I need to write the code to set up the model service myself and have that running to host this model and expose this model inference API. Along the process, I will also need to do this due diligence to do the profiling on the models to make sure the model performance is acceptable and reasonable, both in terms of relevance performance as well as this infra performance, like model inference latency. So, and after that, I will need to update my credential manager with my access token. And I will need to update my code script to talk with model serving service instead of OpenAI, because how I prepare the HTTP requests need to be changed. Apart from all those things, there's other things I need to take into consideration. Cost control. I need to put some guardrails about cost control to prevent any enthusiastic new junior employees to blow up my billing with a lot of experiments. And I also need to make sure this network is secure. When components talk with each other, better to go through the private link instead of going through the public network. And I need to have this monitor there to make sure my service and my code is running healthy. Apart from that, once this computation is done, it also needs to work with the downstream applications. I need a dashboard to display the result. And better to work with delta sharing so that it can open up to new cases, or delta live table for continuous computation. So, but I am just a business analyst. I am not a team of 20 experienced engineers who are specialized in system infra and machine learning. I just cannot do this. This is too much for me. So now you can see the gap. SQL users who are usually business analysts or ETL developers, they are the ones with the most context and insights about the business. And they are the ones who really knows how to apply large language model to benefit their business. However, because of this red big monster box in the middle, it's extremely hard for them to apply large language model in their daily job that can really reap those business benefit and impact. So here is what Databricks comes into play. Databricks unlocks large language model capabilities to all SQL users in a productionized, scalable, and safe way. So we are providing AI functions here, of course, together with the whole ecosystem, to hide all the complications I have just talked in the previous slides and provide a simple and seamless end user experience. Going back to this example, I have my data lake. I have my reviews table in the data lake, and I have OpenAI API. What do? Just one SQL statement. I call select AI generate text from reviews. And with its AI generate text, supplied with the right prompt, give that the column name, the right column name, which actually store the reviews. That's it. It will generate that like the taggings you showed in the previous slides automatically for all the rows in the tables. So what if I want to use my own large language model? I want to host my own large language model. It's also simple. So you can just do a few clicks to deploy the model to Databricks model serving service. If you want that to be optimized, that's also easy. Just mark it, just tag it. The Databricks model serving service is going to pick up the queue and apply all those state-of-the-art optimization technologies automatically for you. You don't need to take care of, like, you don't need to touch any of that. So once this model serving endpoint has been exposed, you just replace this AI generate text with another SQL function called AI query and change the parameters along the way. And that's it. So in the future, we do plan to unify those SQL functions. So like when you switch the backend of large language model provider, say you switch from OpenAI to Databricks model serving service or something else, all you need to do is just change one parameter which specifies the provider. You don't need to change the whole SQL functions, but that's in the future. So with all those things said, I'm going to hand over the stage to my colleague Shitao to give a live demo about how to use how to use AI functions to achieve like some like really interesting and more complicated business use case. Thanks.
Yeah, thanks to you for introducing the AI functions. So it's demo time. It's an exciting time. So let's say we have imagine we have a call center that has thousands of millions of raw phone call audios from our customers. And as an analyst, we want to understand some business insights from it. For example, what are the majority of our customers' concerns about us? Are the customers happy or not happy with us? And before we dig into further, let's see in the demo, what do we have in this delta table? So as you can see, we have two columns. One is the title, it's a string. And then the content is just a raw audio as a binary. Yeah, we have a binary format in SQL. But imagine without AI functions, can we get any useful insights or information from these bytes? Absolutely no way, right? So in order to understand it, we need to transcribe it and then summarize it. Well, the first very, very, very naive approach is we can simply just listen to it.
I don't know a whole lot. I'm 21 years old and I don't have any children.
You don't have any children yet?
But I babysat and stuff, and I think about having.
Yeah, I just picked the one row from this table. You can see the authors, the two women is talking about the babysitting, but without AI functions, if we want to understand this, we need some machine learning model, right? We first need to transcribe it, and then we need some LLM to summarize this content. If we don't have anything in SQL, we have to ask our machine learning engineer or data scientist, saying, hey, can you build up a pipeline for us, or can we deploy a model to do this? It's painful, and it's a headache. We want to do this in SQL, right? And now, with the AI function, the magic is happening. We are seeing a magic here with a simple SQL statement. Let's zoom it. With one simple SQL statement, we have two functions. First, we transcribe, and then we summarize as simple as these two functions with a select statement. We get the transcription and the summarization of this 4 minutes audio. Here, the speaker is talking about the babysitting, and they have trouble finding a daycare. As simple as that. You get it from a binary audio stored in your data lake. And I'm not a magician. Let's see what's behind, and let's see what's behind this magic, right? So this summarize and transcribe is a two function we defined on our Unity catalog. Let's see the first one, the summarize. Behind the scenes, it's called the AI generated text. You only have to provide three things: one prompt, and then one model name, and then the secret. And that's it. All you need is these three things. And then we are talking to the OpenAI's ChatGPT directly from SQL using this AI generated text. The prompt is a task prompt, like summarize the following text in this case. And then the ChatGPT is summarizing the text for you in SQL. As simple as you can show. You can see, you don't have to worry about how would you invoke the endpoint. You don't have to deserialize the data out of the SQL. We are doing it for you. And the next function we see is a transcribe. Behind the transcribe, we are returning the AI query, which is invoking our Databricks endpoint. And we can see here, this is a Whisper model hosted by Databricks, model serving endpoint, GPU serving serverless, model is trained on, and hosted on Databricks, everything on Databricks. And we are invoking it directly here from the SQL. And you only need to tell us what data you are going to feed in, what's the return type. For example, here, very simple. You're going to transcribe it to string. And then the AI query is invoking this and transcribe the content for you. So you may also notice I have another function register here. It's like a more complicated prompt. It's letting the ChatGPT to classify the content for me. It's like a classify the text into 4 categories: frustrated, happy, neutral, or satisfied. And the best part about SQL is we can make some dashboard. And this dashboard is just the select statement for the sentiment analysis with a simple SQL statement. You get this nice dashboard. Previously, you couldn't imagine you can do it just in one single SQL statement. And that's all for my demo. Hope you all enjoyed it. And be sure to try it on Databricks with this new feature. Thank you, everyone.